When we think about area classification, our minds automatically turn to thoughts of massive oil and gas facilities, maybe some mining operations, and the like. But hazardous locations are more prevalent than you may think, and they all require area classification. Welcome to the session Considerations for Classifying Cannabis, Hydrogen, Food and Beverage, and Other Process Facilities with Allan Bozek. Allan is the General Manager and Principal Instructor at EngWorks, a provider of consulting engineering expertise and training in hazardous locations. A recognized expert in the field, he has over 33 years of experience in hazardous locations. Without further ado, please welcome Allan Bozek to EBPowerCon.
Thank you, Anthony. A pleasure to everyone who's joining us today. As Anthony mentioned, we're going to be talking about hazardous area classification, and I'm going to make the assumption that most of you out there are familiar with the term and why it's necessary. But what I'd like to do is more or less dive into some more unique situations, you might say, that are out there. As Anthony mentioned, we're all familiar with, massive petrochemical facilities and oil and gas operations. And of course, all these types of facilities and hazardous area classification is essential and is rarely overlooked. But when we get into some of these smaller manufacturing operations and some of these smaller type facilities, quite often the area classification is overlooked because mainly it covers just maybe a small portion of the process. And because it's just a small portion of the process, sometimes it does get overlooked, and that's when some problems can occur. So what I'd like to do today is just talk about some of these situations where you might find a hazardous area classification, and when you do see one, what you can do to mitigate the hazard. So the agenda today, we'll talk a bit about hazardous area classification. We'll talk about why we need it, who needs this information, what do they need to know, I think is also important. When do they need this information, and who's responsible for providing it. And then we're going to put it in the context of a manufacturing facility, some food production facility, laboratories. We're going to talk about wastewater treatment and something brand new in our industry, cannabis production and hydrogen applications. Both these areas have hazardous locations, and there have been some recent incidents that I'd like to maybe bring to your attention, highlighting the need for a proper design in these types of facilities. So let's start with the need for classification. Well, best way to talk about the need for classification is maybe just to briefly talk about the fire triangle. I think we're all aware that, in order to have fire or combustion, you need three things. You need oxygen, you need a fuel source, and you need a heat or ignition source. Now, when we talk about hazardous area classification, we're talking about that fuel side of the triangle. We want to understand whether there is a hazard that exists. And it could be in the form of a flammable gas hazard, or it could be in the form of a combustible dust hazard. Now, this information is important because it helps us define the equipment certifications and the wiring methods for a facility. And this is all defined in the Canadian Electrical Code. In fact, the whole concept of a classified area comes from the Canadian Electrical Code in Rule 18004, where it basically describes what a classified location is. Now, the area classification is also used by other people to determine safe operating work practices. It's a useful tool for conveying to your workers where the hazards lie. And with the proper map, you can determine, an employee or a worker can determine where there's a possibility of a flammable hazard and take the appropriate precautions when he's working in those areas. So it serves a dual function. It helps us select the equipment and the wiring methods, and it also defines the safe operating work practices in those areas. So where is it needed? Well, that's a simple question. Wherever there's a hazardous area class, or wherever there is a hazardous location, is where it's needed. And of course, that, as I mentioned before, it's been defined in the Canadian Electrical Code. The hazardous location is any location where there's a flammable gas or liquid, a combustible dust or flying, or an ignitable fiber or material that could ignite. And any location that has these sort of hazards, you are obligated by code and therefore by law to provide a classification design for your facility. So on that note, I want to talk about several different types of situations where you'll have a hazardous location. And I want to premise it with some recent incidents in these types of areas. Let's start with manufacturing operations. Very recently, a couple of weeks ago, we had an incident in the Ottawa area where we had a manufacturing facility completely destroyed as a result of an explosion. And this company, we're not quite sure about the details of the accident, but it suffered a catastrophic explosion where 6 people were killed and 2 were injured. And you wouldn't expect that a manufacturing facility constructing tanks would have this sort of a hazard within its operations. But somewhere in that facility, there was a large release of flammable materials that were ignited. Now, another significant accident that happened in Canada here was the Burns Lake, BC explosion. This was a sawmill explosion that happened in British Columbia a couple of years back. And well, actually, it was more than about 10 years back, I believe it occurred. And that explosion actually killed 2 workers and injured 19 people. And that was a result of a combustible dust hazard that was not mitigated. The facility was handling sawdust from these pine beetle logs that they were sawing up, and that the pine beetle logs were very, very dry, and it created a very, very fine dust particle that settled on a variety of equipment. And somewhere in that situation, the dust was knocked loose and created a large explosive atmosphere within that building that was ignited by some device and such. Unfortunately, a very similar accident happened a couple of months later in Prince George, BC, at the Lakeland sawmill. And again, 2 people were killed with many others injured. These 2 incidences actually prompted Technical Safety BC to clamp down on a lot of the sawmill operations to ensure that they were properly assessing the hazards within their facilities and that they were taking the necessary precautions to ensure worker safety. Within any manufacturing process, there could be certain areas that have a classified location. One example is with regards to painting operations. We have a lot of manufacturing facilities in the automotive industry, for example, that have paint booths and other appliance manufacturers that basically just coat their products with different materials, and many times these materials are flammable. So typically, when you're dealing with painting operations, there is going to be a classified area around these areas, and it's you must have it classified in order to stay code compliant. The same goes for woodworking manufacturing processes. We discussed the sawmill incidents, of course, in BC, but when you take a 2x4 and you cut it, obviously you create a dust hazard. And of course, depending on the particle size and the size of your operation, the wood dust from these operations can collect on elevated surfaces and create a combustible dust hazard within the area. Now, these types of applications can be a little bit challenging because a lot of the equipment, of course, in these areas is not hazardous rated, so they don't have a certification for a classified area. And this means that you have to deal with the hazard from an operational perspective, which means you have to be very cognizant of your housekeeping procedures in the area, which will have an ultimate impact on how the location is classified.
Before we move on to slide 8, I do have a question for you over some of the things that you've brought up, and actually just looking at that woodworking shop. What What separates, what differentiates, say, the woodworking shop with, with the dust and the wood cutting that they're doing there versus, say, somebody outdoors who's building your deck, or you yourself are sawing lumber and building your own deck?
Well, the nature of the hazard is determined whether the dust hazard is confined. You need confinement for an explosion to occur in a combustible dust hazard. If you were cutting your deck using your saw outdoors, there's very little probability that you would have a fire or explosion in those centers because you're outdoors. But as soon as you confine a combustible dust and you create elevated surfaces where this dust can collect. And then you have the situation where this dust is knocked loose. It could be, well, for instance, I believe in one of the explosions in BC there, the incident that created the dust to rain down was because a semi-trailer truck was backing up to a loading dock. It struck the loading dock just a little bit too hard, and that caused all the dust particles on elevated surfaces to rain down inside the facility. And unfortunately, it found an ignition source, and that created the massive explosion that resulted in fatalities and injuries. So with combustible dust type applications, you have to have confinement. That's not true for flammable gas environments. They have to be addressed a little bit differently. So it's a function of the analysis when you do that. And generally speaking, if it's confined, it could be dangerous. Now, other manufacturing processes that often create a classified area that may not necessarily be acknowledged include printing press applications and such. A lot of these type applications, they use flammable solvents in the inks and such. And of course, when you have a machine that's using a fair bit of solvent and is open to atmosphere, you will have flammable emissions from the equipment itself. And so you have to ensure that not only the equipment is properly certified for that type of application, but the surrounding infrastructure is also appropriately designed. Now, you can, on the left here, we have an open type of printing press operation there, and you can see that the solvent there, if it was flammable, would actually evaporate into the entire room. So everything inside that room would have to be properly classified for a safe installation. Now on the right there, this is a more modern design printing press, and you can see that they've enclosed all the presses themselves, and they have an elaborate ventilation system to ensure that no flammable vapors can escape from the equipment itself. And that allows you to basically use non-hazardous rated equipment in the vicinity of the machinery without creating a hazard. But again, this needs to be assessed. And so you do have to have some expertise in terms of determining what would be the extent of the classification surrounding this equipment. Now, in many food production facilities, we also have hazards, and typically there'll be combustible dust type hazards. And one of the more significant events that occurred with respect to food production facilities was the Imperial Sugar refinery explosion back in 2008. This was a manufacturing or a food production facility in Georgia that, of course, packaged and sugar. And they had massive conveyor lines and silos, and it was quite a large operation. And unfortunately, they didn't pay a whole lot of attention to housekeeping in this facility, and an unfortunate event occurred which caused an explosion that caused 17 fatalities and injured over 40 people. This event was very significant, particularly in the US, because it prompted OSHA, Occupational Health and Safety in the US, to clamp down on facilities that handle combustible dust. And following this incident, the inspectors, came down hard on a lot of facilities that had combustible dust hazards. And it also prompted an education program for industry in making everyone aware of the hazards and the potential dangers that it could cause. Now with food production, it's all about powdered ingredients. The ingredients, they're crushed, they're moved, they're conveyed, they're bagged, and all these types of facilities, can create combustible dust emissions, and of course, if we don't mitigate these combustible dust emissions, they can create a hazard over time. And as I mentioned before, when you're dealing with combustible dust hazards, your first line of defense is housekeeping. You have to have a good, solid housekeeping policy in place. And for the most part, this housekeeping policy will have a huge impact on the area classification design for your equipment. So if you can maintain a clean environment, it's very possible that the majority of your equipment can be designated non-hazardous. From a certification perspective. But if you have combustible dust accumulations on surfaces and elevated surfaces, that changes the classification, and it drives you towards equipment that needs to be certified for the location. And in many cases, that equipment may not be available. So the whole idea of designing a food production facility, that has to be coordinated with the classification design and the equipment you buy. Another application with respect to food production that often comes up is distillery operations. Of course, alcohol is flammable, and particularly when you get into large quantities, these distilleries start to look like little refineries, and you have to ensure that the workers that are handling the materials in these facilities are kept safe. And this is particularly true when you're opening and closing vessels. If you're adding mash to a vessel to create, it could be whiskey, rye, or beer, or otherwise. Just the fact when you open that vessel, there could be a release of flammable materials, and of course, if there's an ignition source in the area, it could potentially create an explosion or fire. So this is one area I see in my experience that tends to be overlooked. The people, when they buy the equipment, they don't necessarily realize that it could create a flammable atmosphere, and it needs to be considered before you buy your equipment, because it could be a very expensive mistake to make if you don't buy the right equipment for the classified area.
I'm glad you brought up the distilleries and spirits and wine and beer and stuff like that, because you probably noticed this as well too. The popping up of a microbrewery here, microbrewery there, and one would hope that they're taking this sort of good information and applying it to their operations.
Well, and Anthony, you're absolutely right about that. But in my experience, a lot of these microbrewery type operations, they don't think about this until after the fact. And the facility is, has been constructed, all the equipment has been installed and interconnected. And then of course the electrical inspector comes along and he says, well, where's your classification documents? And he won't basically give the connection permit until he's satisfied that the hazard has been addressed. So, with these microbreweries and such, they're created by entrepreneurs, and entrepreneurs may know a lot about, brewery operations or distillery operations, but they may not necessarily know about the engineering design functions associated with these types of facilities. So, and this is where it's really helpful to have a good consultant on board to help you, to guide you through these types of situations. Laboratories. Now, laboratories are quite an interesting challenge, because with laboratories, you have a lot of, you could have a variety of flammable materials within the laboratory that you may have a scientist or a researcher handling, and he's pouring these chemicals from container to container, and he's possibly, there could be some open flames in these areas too, and this can create some problems. Again, this is another one of those situations where you have to have an assessment done. The vast majority of laboratory equipment out there is not hazardous location rated, which means you have to create a non-hazardous environment within your laboratory environment. And this involves actually, to a large degree, ventilation design. So so you start off the objective saying, okay, I need a non-hazardous area so I can place my equipment in this area. What do I need to do with the ventilation system to have sufficient air movement to dissipate any hazard? Now, generally speaking, that can be done through fume hoods or otherwise, but if it's not done properly, though, you can end up with some situations like we have here. For example, the University of Hawaii had an incident in 2015 where a researcher was injured. And what was happening there is within this laboratory, they were preparing gas mixtures using hydrogen and oxygen and carbon dioxide. And somehow through the transfer process, there was a spark that created an explosion. And of course, that resulted in the lab being destroyed. There was another facility in Singapore in 2015. This was a gas manufacturing facility that had a lab within their operations to test test their product and such. Again, there was a release inside that lab. It found a ignition source, and an explosion occurred, and that resulted in one death. And one of the more significant explosions occurred at the T2 laboratories in Florida back in 2007. This is another one of those landmark type of incidences that prompted OSHA to take action. In that particular facility, they were manufacturing gasoline additives, and they had a certain process that was exothermic, and they had a runaway exothermic reaction that they couldn't control that resulted into a major explosion. And the interesting part about this particular application is that it was kind of a scaled up laboratory process. And they had run this experiment almost 175 times without incident. And then one day they ran the process simulator or the process, and it exploded. So, just because you haven't had an accident in the past, it doesn't mean you'll have one in the future. And it's something to consider. Just because you may have just been lucky up to that point, and you certainly don't want to be relying on luck to maintain the safety of your facility. Challenge with laboratories, as I mentioned, is that you have a large amount of non-hazardous rated instrumentation equipment. You can't buy the equipment in a HAZLOC rating, and there's just not enough of a market to justify that. So most manufacturers just do a non-hazardous rating. You have to basically ensure your lab is properly ventilated. You also have to create the operational procedures where if there's any flammable materials being handled or being transferred between containers, that they're always done under a fume hood. And this can create a rather complex ventilation scheme for a laboratory environment, and it needs to be factored into the cost of designing and constructing a laboratory. So, one of the more challenging applications we see in the hazardous area classification world. Now, another industry where we see a lot of hazardous locations that are maybe overlooked in many facilities is wastewater treatment. And we've seen some accidents in the wastewater treatment side of the business. We had an accident in Pickering in 2014 where we had an odor control building that was basically just designed to remove the stink from the wastewater treatment process. But of course, when they remove these odors, there's a certain amount of flammables in the air or in the process stream there. And in this particular situation, there was a buildup of methane gas resulting from the process, caused an explosion and fire in the treatment plant, and effectively shut it down. Fortunately, there was no one injured in this, there's no one injured in this particular incident, so that was very fortunate. There was another major explosion in Avonmouth in the UK, where actually we had 4 workers that were killed and a 5th injured. And again, that was a part of the process where they were basically processing biogas from the sewage, and for somehow there was an ignition that occurred, and of course it blew the roof off of a storage tank, and there were workers in the vicinity that were injured. And a very major explosion occurred in water treatment plant in Chicago, Illinois in 2018, where again, 10 workers were injured. So wastewater treatment, when you're dealing with these types of facilities, they do warrant a classification design. And you know, with wastewater treatment, it's kind of an interesting process. It's an interesting process in the fact that it's a biological process that creates the hazard. It's not like it's a flammable gas release where you have flammable gas contained by a pipe that is suddenly released and it creates a flammable atmosphere. It's a slowly evolving process. And of course, what happens is, as the sewage decomposes within the process, methane is given off. And if it's not properly ventilated, it can build up in enclosed areas. Now, mitigating the hazard in wastewater treatment is not a difficult process. You just simply have to ensure that you have adequate ventilation within your buildings and enclosed areas. And if you have that in play, then the likelihood of an explosion is extremely low. So another good example where ventilation plays a huge role in the safety of the installation.
I'm glad you bring up this example of wastewater treatment plants and specifically biogas, because that is something that I hear, read, and report on more regularly these days, about communities, trying to get energy from their wastewater operations. So I'm hopefully they'll take note of this slide.
Well, and that's good because historically we used just to flare off that usable energy, and now we're collecting that energy, we're compressing it, we're giving it to the utility. They can sell it to their customers, and of course when you start adding these types of equipment to the process, you get into compression, and it starts to look a little bit more like a petrochemical facility than a wastewater treatment plant. So, and then at that point there, you're dealing with pipes with gases, and it's a little bit more straightforward from the classification perspective. But it's the biological side of things where most of the accidents occur because, people maybe discount the hazard in those areas. Now, here's a brand new hazard or industry that's had some incidents recently. Cannabis production. Okay, now you have to kind of think about, well, how can there be a hazardous location with related to the cannabis production? Well, in fact, a lot of these new manufacturing firms in cannabis production are creating extracts. This could be THC or CBD type extracts. And in order to extract these chemicals from the hemp, they have to basically use solvents. And so what they do is they basically will soak a large amount of hemp in a butane or a pentane solvent, and then that dissolves out the CBD, THC oils, and then they have to basically refine it. Distill it from that extraction, and of course this is starting to create a bit more of a process than just simply growing the plant itself. And because this is an extremely new industry, there's a lot of new players into it. A lot of new players that maybe don't understand the hazards involved. It's a little bit like the microbrewery type of situation, but I think even to a worse extent. And already, we've only gone through, legalization in the U.S. here in Canada for maybe 2 or 3 years, and already we have a laundry list of incidents that have occurred. There was an explosion at a Santa Fe, New Mexico facility where two people were injured. Another one at a Los Angeles facility where 2 people were killed, and 11 firefighters were injured actually fighting the blaze. There was another facility in Los Angeles where 3 workers were seriously injured, and it took 150 firefighters to control the blaze. So you can see that when you do have an explosion in one of these facilities, it would appear that there's a fair amount of material being stored there too, because to warrant 150 firefighters to control a blaze means that there's a fair bit of flammable material in the area. Again, cannabis production is also particularly dangerous in the sense that you're opening the process to add material in or extract material. And anytime you open a closed process, you have a high probability of a release. And of course, if you're dealing with some volatile materials like butane or pentane materials, that will most definitely create a hazardous location around the equipment that's handling this equipment. And in my own experience too, it would relate to the cannabis facilities. A lot of the cannabis facilities kind of go from a laboratory to a production type of environment without changing the equipment. So what they do is they scale up laboratory equipment, and laboratory equipment is not necessarily suitable for production type operations. The last thing you want is a whole bunch of glass, vessels and fixtures like this, and substituted for production facilities where you would normally have stainless steel vessels and proper equipment that is a little bit more robust and can better contain a flammable hazard should you have one. So again, it's a function that the industry is young. The people in the industry are entrepreneurial, and quite often they may overlook the hazards that they create when they develop their facilities. So it's worthwhile paying close attention to these types of applications. Now, the other up and coming industry is the hydrogen industry. And as we all know, everybody is excited about hydrogen. It's the fuel of the future. It's going to be used for long haul trucking. It's going to be used for energy storage. It can be used as a green battery in many ways. You can, I've seen lots of applications being discussed where, they take wind farms or solar type farms, and if they have excess energy, rather than putting it into a battery bank, they create hydrogen out of it. And this is a very novel approach. However, you have to recognize that hydrogen is explosive, extremely explosive. It is one of those materials that is very hard to confine. It has a very low ignition threshold, and it, because it's such a small molecule, it just leaks everywhere. So you have to be any facilities handling hydrogen need to be carefully considered. And again, this is another industry that has a long laundry list of accidents that have occurred. We've had explosions in power plants. Many power plants actually use hydrogen as a cooling medium for their generators, and of course that requires them to contain that hydrogen and properly handle its use. There was another accident in Santa Clara, California recently in 2019 that just about, it constrained the commercial availability of hydrogen for a few months because of the explosion at the facility. And it was just a result of a small little container, as you see there, developing a rupture. But that small little container contained, released over 250 kilograms of hydrogen, and actually ended up creating quite a bit of damage to the production facility. And of course, there's some discussion about hydrogen fueling stations, and of course, for vehicles and for cars, and we can see this for long haul trucking. We're going to see a lot of refueling facilities there. We had an explosion at a hydrogen fueling station in Sandvika, Norway. And the blast was so large that it actually set off airbags in nearby cars. So just to give you some idea of the explosive power of hydrogen. So with the hydrogen applications, these are going to be challenging applications, especially in the environment moving forward. Historically, most of the hydrogen manufacturing operations were contained within large industrial facilities. They're used for hydrocracking, for upgrading, and for other industrial uses. And generally speaking, when you have a process contained within an industrial facility, they're properly engineered with an appropriate classification provided, and the hazard is properly assessed. However, moving forward, we're going to be going into kind of a decentralized hydrogen implementation where we're going to have separate modules scattered all over the place. And they could be adjacent a wind farm, they could be adjacent a fueling station, and a lot of these smaller applications, they want to package everything in a sea can or something similar for portability, and this means that the classification design of that sea can needs to be carefully considered, because you will be placing these things a lot closer to where the public is, and a lot of the equipment we're finding, particularly in electrolyzer type applications, is not necessarily hazardous locations rated, which means that, again, you have to go back to a ventilation design. With hydrogen for the most part is not terribly dangerous in outdoor applications, because it's such a light molecule, it rapidly dissipates on release. However, if you enclose a hydrogen application, then it becomes dangerous. Even a very, very small leak will cause a pool of hydrogen or a hydrogen gas cloud to collect in the upper areas of that structure. And if you have some equipment in that upper areas, it could be a light or perhaps a heater, a fired heater or something like that. If the hydrogen contacts that, and it can explode. And you may not even detect it at a floor level, but at ceiling level, you have an explosive atmosphere. So particularly with enclosed hydrogen applications, it warrants an extra degree of care. And certainly, when you're dealing with such things as these CCAN modules where you're packaging electrolyzer type equipment, it needs to be carefully considered at the very beginning of a project to ensure that the equipment you're selecting is appropriate. So we've kind of briefly talked about some of those situations where a classification design is warranted. And I just want to talk a little bit briefly about the risk assessment process and some things to consider. First of all, it's required by law. As I mentioned, the Canadian Electrical Code says that if you have any flammable materials in your process, you're obligated to do a classification design, and you need to do that so that your inspector, so that your installer will know what equipment to select, what wiring methods to use, and the inspector can basically verify that at the end of the job. The other thing about an area classification is it's premised on the flammable mixture being present under normal and defined abnormal conditions. Now, a lot of the accidents I reviewed earlier are what we call catastrophic events. This is where a large amount of material has been released, and of course it found an ignition source of some kind and created the explosion. But when we deal with a hazardous area classification, we're looking at a process under normal operating conditions, and we expect that there's going to be a small amount of material released. And so if there's a small amount of material released, we have to ensure that any equipment in that area is properly certified so it doesn't create an explosion hazard. You can't assume that every process is tight. That's bad thinking. You have to assume that there will be leakage from your process, and you have to mitigate that leakage by selecting the appropriate equipment or operating procedures. Now, really, really important, and this is a mistake made all too often, is that people buy the equipment before they do the classification design. This is bad news, because what it often happens is if you begin to force a classification design rather than properly assess the hazard. Now, as I mentioned before, there are some situations where you can't get equipment in a particular certification design, and there's ways of mitigating those types of situations. But where it becomes a problem is when someone purchases a piece of equipment and then wants a classification to meet the certification requirements of the equipment, and that is ass backwards. You have to assess the hazard first, and then you buy your equipment. If you do the opposite, you buy a piece of equipment and then you do a hazardous area classification, there could be the possibility that the equipment you purchase is not suitable for the environment. And then at that point, you have a problem. Either you have to retrofit that equipment, you have to return it to the manufacturers if that's even possible. Whatever happens, it's going to be expensive. And so you're much better to get your classification design done early in the project, Make sure you understand the hazard, and then select your equipment, and that reduces any kind of risk of this sort of mistake being made. The other thing I want to say about this whole classification design process is it's the multidisciplinary process. It's required by the electrical engineers and the electricians, which is because it impacts the equipment and the wiring methods they use. But the actual process of doing a classification design has nothing to do with electricity. It has everything to do with chemical processes. It has everything to do with mechanical containment. It has everything to do with ventilation. These are topics typically outside the discipline of electrical. And so you have to recognize this. And so when you are creating a design, you have to make sure that you have the appropriate people involved, or at least understand the key factors in performing the analysis and ensuring that it's properly done. Now, once we got our classification design in place, there's going to be a number of people that are going to use this information, and at this point it becomes a very important document, because for one thing, the engineers using this documentation, they're going to basically buy the equipment based on the specifications provided by the classification design. It also impacts equipment placement. The design of your facility is going to be impacted. How close the equipment needs to be to sources of release and such will have a big impact. And as I mentioned before, you need to have an engineer involved doing the ventilation design in these facilities so that you have sufficient air movement to mitigate the hazard as best you can. Now, once you have this information, of course, you're gonna buy it from an equipment supplier, and the equipment supplier needs to know this information too, because that impacts the components he incorporates into his skid packages. And again, that's a function of the certification requirements of the end use location. Installers, of course, the electricians, they use the Canadian Electrical Code to basically, install equipment in facilities, and of course, Section 18 within the Canadian Electrical Code deals exclusively with hazardous locations. So, if an installer doesn't know what that an area is classified or what the classification can be, he really can't do his job. And of course, that's going to lead to problems when the inspector comes along. The inspector comes along, he's going to want to see that this area has been properly classified, and then he's going to ask for the documentation. He's going to look at the documentation. He's going to look at the installation, and then he's going to make an assessment as to whether it's code compliant or not. If he doesn't have that documentation in place, he can't make the assessment. He just goes home, and he leaves it up to you to get that assessment done after the fact. And of course, that becomes problematic, because now you're back in that chicken or egg thing, right? Where if you haven't done the classification, but you bought the equipment, and if the equipment isn't appropriate for the classification, you have all of a sudden a very expensive problem. So again, this needs to be done in a sequential fashion so that you avoid these types of situations. And the other very, very important people that need this is your own workers, the operations people. They need to know where the hazard exists and what the nature of the hazard is, because as soon as you have certain activities within a classified area, it triggers a number of occupational health and safety considerations, and that might be related to safe work procedures or hot work permitting. In many facilities, what they do is they use the area classification plot plan drawing is kind of a hazard drawing. So, and they post it in a prominent location so that any workers, if they're working in that facility, can quickly verify where are the hazards and where are not the hazards, and what can I do over here and what can I do there. And, it becomes a working document over the life of the facility, rather than just a design document that's only used during the construction of the facility. So it does, it has a lifespan, and it should be maintained over for the life of the facility for this very reason. So with respect to a classification design, what do they need to know? Well, first of all, they need to know the zone or the division classification. This directly impacts the type of equipment that's suitable for the area. They need to know the extent of the area. Where's the classification end, and where can I use equipment that needs to be certified for HAZLOC, and where can I get away with just non-hazardous rated equipment? That extent becomes important. The group classification, this is related to the characteristics of the materials themselves. And the group classification will impact the design of explosion-proof enclosures and intrinsically safe circuits within classified areas. And last but not least is the auto ignition temperature of the flammable materials. This is related to when the materials will self-ignite due to temperature, surface temperature. And the Canadian Electrical Code stipulates that you can't install equipment that operates at surface temperatures that exceed the auto ignition temperature of the flammable materials. So you need these 4 pieces of information before you can select your equipment or select the appropriate wiring methods for your particular facility. So, if you are reviewing documentation or if you're creating documentation, you need to ensure that these 4 key pieces of information are included. So when do you need the information? Well, as I alluded to before, in the early stages of the project, it's highly recommended that you do a classification design or a preliminary classification design before you purchase any major equipment. And this is to avoid the possibility of selecting the wrong type of equipment for the hazard that's present. In many cases, in larger facilities, you may have to have preliminary design where you have a classification design that's based on preliminary design documents, and then optimize later in the design during the detailed design phase, where you can optimize the extents of the various classified areas and kind of fine tune the documentation to you might say optimize design. But it's very important that you consider it early in a project. I would not ever recommend waiting till the last minute to get this documentation. Typically, if someone is calling about a last minute area classification design, it's because the electrical inspector is asking for it. And of course, that's way too late. And who's responsible for providing it? Well, it's the owner who's responsible. The owner is responsible for ensuring that he provides a safe work environment for his workers. And it's up to the owner to contract the appropriate technical personnel who are competent in doing this task. And generally, competency is going to be somewhat related to the industry or the specialty of that person that's doing the classification design. So I would also like to indicate that the Canadian Electrical Code requires that the classification documentation be issued under a professional seal. That's because this is a key safety document related to the occupational health and safety. So by applying a professional seal to a classification drawing, you're indicating that you're competent in doing the work. And I think it's very dangerous to do this task without understanding the nature of the materials, the nature of the hazard, and being properly trained in performing this whole task. Competence is one of the biggest challenges we have in hazardous locations at the moment. Over the years, it's becoming increasingly complex, mainly because we are adopting IEC standards and creating new criteria for assessment and such. And so I would not advise anybody to take on this task unless they feel that they have some competence in doing the task. Because again, by applying that seal, you're indicating that you are competent in performing it, and your customer is assuming that you have the competence to deliver a good design. And to that note, in 2015, the Section 18 subcommittee for the Canadian Electrical Code recognized that there was an issue of competence with respect to hazardous locations. And so they created a new appendix. It was Appendix L of the Canadian Electrical Code, and it has an extensive list of engineering guidelines related to hazardous area classification. It talks about some of the considerations you should have related to classification design, and it talks a lot about the documentation requirements. Historically, many designs have never been properly documented, and this is problematic because if you ever have to go in and modify a design that's just simply based on a drawing, with no supporting documentation, it's very difficult to know what the premise of that drawing might be. And myself, who have done this on many occasions, have simply said that, listen, if you don't have a documented design, I can't touch it because I don't know what the original premise was, and I'm going to have to start over. And rather than having to update a document that's only for a small part of the premise, I end up having to do the entire premise because it was never properly documented in the beginning. So highly recommending that when you do a classification design or receive a classification design, that you have some sort of background documentation that supports the rationale for the design. And when you have that in place, then you have a design that can be maintained over the life of the facility. With that, I think I don't have much more to say. Anthony, you have any questions you might want to say?
One of the things that I know you highlighted a few times, because I was taking notes here, is the importance of housekeeping being very key.
Well, that's extremely important in combustible dust type applications. Typically, when we do a combustible dust classification design, that's the first thing we want to see is where's your housekeeping procedures? And if they don't have the housekeeping procedures in place, we're helping them write it. And that's one step towards a safer facility, is just be putting these procedures in place, making sure your employees know that, and they implement them on a regular basis. The trouble with combustible dust facilities is it's an ongoing process. You can't skip a day. If your plant is in operation, you got to be cleaning. You miss a day of cleaning, the hazard comes back, and so that's where housekeeping comes into play.
I think we'll wrap it up there. You've given me and you've given us a lot to think about when it comes to area classification, particularly as it applies to all these different other applications, whether it's wastewater, distilleries, some things that may not, come to mind when people think about area classification, hazardous locations. So I appreciate you bringing that to us. Thank you for your time in delivering this information to us, Alan.
Thank you so much, Anthony, and thank you to everyone out there.